Let's suppose that you're a student or an educator and that you're learning or trying to teach a subject such as physics or mathematics or even chemistry, biology, economics, a subject that has a computational modeling component, at least a computational modeling component in modern industry, but perhaps you believe that computation has a role to play in education. For example, computation can help develop or correct intuition. It can help develop or create insights. And I think there's something, it's been recognized that sort of the productive struggle, the creative process of bringing together sort of theory, really understanding it deeply, using computational modeling can really kind of contribute to genuine learning. So you look around and you look for software that can help you with this task, and you find you're caught between a sort of a rock and a hard place. On the one hand, there are the professional software engineering tools, and they have a great kind of experience in terms of the quality of the environment and the amount it helps you. But the software engineering bar is really just kind of like too high. And let's face it, many of those tools are trying to solve problems that you don't have to address. I mean, you're not trying to produce a piece of commercial software. On the other hand, there seem to be some educational tools out there that, for various reasons, don't seem to fit your needs. Um, this was my dilemma when about 7 or so years ago, was looking for a software engineering tool to help me visualize some mathematical physics. And I wasn't just trying to solve this problem for myself. I was really trying to think about how can I let other people inherit, whatever solution I came up with. So as I say, tools like Java, Scala, and so forth, and the environments that they had built around them were just way too complicated and unnecessary kind of complication for what I was looking for. But the other environments, the educational environments that are available, really, I would say the fundamental thing that really was problematic for me was that they didn't seem to scale to the complexity of problem I was trying to solve. Now, I happen to think that pretty much every software problem turns out to be non-trivial, or it grows to be non-trivial. And, I think many people who start out with, simple sort of one page or one page of code solutions quickly find that it becomes either a sort of spaghetti mess or it becomes incomprehensible. And that really doesn't do anybody any sort of pedagogical kind of like favors, trying to figure out what's going on in code like that. So the scalability, in terms of complexity, was a real problem. There are also a number of other problems. Solutions that were trying to run in the browser but weren't really running the JavaScript engine, like Python interpreters, for example, were too slow by factors of 10 sometimes, and that was going to be a problem for running simulations effectively. I think there was another problem with running languages that weren't inherently JavaScript, was that they didn't interoperate well with the libraries that are out there. And there are some fabulous libraries written in JavaScript for 2D visualization, 3D visualization, statistics, and data visualization. But these would require a shim layer between Python and JavaScript, and that would require documentation, and it just really wasn't going to be a good place to be, having to maintain all that kind of stuff for every single library that is out there. I also found there was a certain degree of inflexibility, that the tools were kind of good at one job. It might have been 3D rendering, for example, but they didn't do a good job of maybe 2D rendering, or they couldn't do some mathematical object that I wanted to do. They maybe have built-in vectors, but they couldn't do a multi-vector or something like that. So I kind of felt like I was going to grow out of these tools, and I wanted something that was going to give me a little bit more power, that would sort of sit halfway between sort of the professional developer's experience and the sort of beginner's kind of coding experience. When I thought about this and thought about what would this tool look like, and after trying various solutions, including like the Python translation route, I kind of came to realize that really anything that ran in the browser would really have to be fundamentally based upon web standards. The normal practices of building a website using HTML, using JavaScript, using CSS. This had to be the bedrock, the foundation. Unfortunately, many things kind of like came together at that time. WebGL was running in the browser. Microsoft came up with TypeScript, which is going gangbusters now in terms of its popularity, and it's kind of like really gaining traction. And it just seemed to be like the perfect solution for this educational arena. Now, my background is really in software engineering, although I had training as a physicist. And so what that meant is I really wanted to bring the best practices from software engineering to bear on sort of the educational problem. So for example, I felt strongly that the code that you develop, you should really store it in GitHub. That's the right place to be. Don't make it hard to do, but you should be able to do that. You should be able to use the libraries that are out there, not just kind of like a limited set. You should be able to do automated testing if that's what you want to do, because you may have some complex mathematical algorithm that you don't want to introduce bugs and you want to sort of make sure it works. Even implementing things like vectors and all of the operations they can do, it can be extremely beneficial to actually add testing. Not required though. And documentation as well. I mean, standards for documentation have evolved in software engineering projects, and they certainly help communicate a lot of the ideas. So I wanted to see things like MathJax built in. I wanted to be able to have code samples in my documentation so I could talk about how the mathematics was implemented in the code. I want to do some other things, like I talked about extensibility already, and mathematical operators were a big deal. They are important from the perspective of making the mathematics look natural, making it possible to implement algebras with just elements and operators. And so I wanted a tool that could do that. Now, I guess I'm kind of spoiled as a software engineer, but I also wanted the editor to be sort of intelligent from the point of view that it should catch mistakes. It should help me in the development process by being able to analyze the code. And many tools that were out there, at the time and still now, just wouldn't be able to do that. Another principle that I've adhered to, and it has actually changed the architecture, is that I want the software to be free. I don't want to create barriers for people to use it, artificial barriers, and I recognize that every software in the end is probably going to have some sort of financial model, but those people who use it for their professions, they should be willing to pay for that. But other people who are just learning, there shouldn't be barriers. That's not a good way to get diversity and to improve scientific literacy. So I wrote a solution that I'm calling STEMCstudio, and this is the channel on which I will tell you about STEMCstudio. So if you're new to this channel, thank you for joining, and if you're returning to this channel, I'm glad that you're back and that you've chosen to invest more time in STEMCstudio. I'm David Holmes. I'm the creator of STEMCstudio, and today I'm actually just going to give you a very high-level overview of STEMCstudio. So what does STEMCstudio look like? Well, here is the homepage of STEMCstudio, and you can see the URL at STEMCstudio.com. it is served from a secure URL. So in fact, it's an HTTPS URL. So type that into your browser. You could use Chrome, you could use Firefox, any of those mainstream browsers have been pretty well tested, and you should land on this page. Now, I'm not going to walk you through all of the options that are on this page. That's going to be a future video. In fact, it'll be the next video, is to actually show you the navigation so that you can basically drive STEMCstudio with confidence. But what I am going to do today is really just kind of like show you how STEMCstudio is different from other tools out there for computational modeling in the educational space. So STEMCstudio does have a bunch of built-in examples. I'm going to make use of one of those examples today, which in this case is a bead on a smooth circular wire. And it's in 2D. Now, STEMCstudio isn't limited to 2D. Like I said, the capabilities of STEMCstudio derive from the fact that you can bring in libraries. It's not that it has libraries burned into the environment, as some tools do, like they burn 3D-ness into the environment. You can basically choose what libraries you want to use and choose the kind of application that you want to kind of create. You can use libraries for 2D, 3D. You can grow your own. You can not use them and write to the canvas, as this example does. You can slow 3D or 2D. The 2D, by the way, uses the JSX graph library by the folks at the University of Bayreuth in Germany, and it's a fabulous 2D Euclidean kind of geometry library, but it can also be purposed for doing 2D physics rendering, things like vectors and so forth, and that'll be the subject of some videos coming up. But with STEMCstudio, you can basically, because we're just kind of like working the web, you can really kind of like go right down to the GPU, the graphics processor unit. You can write shaders, and you can do parallel processing on the shaders and using the shader language. So that's kind of pretty cool. And then Plotly is a fantastic language, is a fantastic library, one that I plan to use a little bit more in future. And I think what I hope to show is that by using these powerful libraries, it's not necessary to dumb down the environment. You can have both a flexible environment and a powerful environment at the same time. Okay, so let's jump into this example here. This is the bead on a smooth circular wire, and immediately what you'll see is over on the left is the Explorer view. These are the files in the project, and as I said, because STEMCstudio is really designed to do non-trivial problems, it really benefits a great deal from the ability to break up your project into multiple files. So we'll see what the standard is for that. I'm going to click on just one file here. Now, in the middle, what you're seeing is a color-coded syntax, color-coded editor, which is great. That adds to the usability. But STEMCstudio is much smarter than that. It's not just about syntax. It actually really truly understands the semantics of the language. The language, as you can see and some of you will recognize, is just JavaScript. Although I should say it's not really just JavaScript, it's actually TypeScript, which looks exactly like JavaScript. It's really, in fact, a superset of JavaScript, where type information has been sort of sprinkled in to the code. Now, if this is done really well at the library level, it's really barely noticeable by the user. And in fact, if you look at this code, you'll be hard-pressed to actually find a place where there is an intentional type annotation. I mean, here's one, okay? And in fact, I'll show how you don't even need to do this kind of stuff in future videos. But for for the rest of it, STEMCstudio and the TypeScript compiler is able to infer the types of various objects. So if I hover over a controller, you can see it knows it's a controller. Okay. If I hover over controller, it picks up the documentation for that, which is in the controller file. Okay. Now you can also do a lot of auto-completion. So if I go to this context, for example, this import context, and hit Control spacebar, it'll actually show me the things that I'm allowed to import at this particular point in the program. So that's a kind of a common theme. When you're building structures, you can use that same thing. So this is part of the power of an intelligent environment. Now, I'll give you an example here. Well, that's okay. Let's just do it right here. Let's say, for example, that I pass in a string in a situation where I was really wanting to have a number. Well, we can detect that. It's a fairly trivial example, but I'm sure you can see how that would prevent any number of bugs that would be difficult to find at runtime with a language that didn't have that kind of capability. Now, something else that I'm kind of very excited about is the features that are provided by the context menu. So let's say I right click on this sim. You can see that I have the ability to find out where this variable is used. I can rename this symbol, and this is not just a sort of a textual rename. This is a semantic rename where it's going to replace sim in the places in the program where it really is, an engine one. I can just demonstrate that. I can type and say engine, hit enter, and you'll see that it's replaced it everywhere in the program. Similarly, you can rename files, and it'll fix up all of the places where that is used. Another way of using the context menu is to actually go to a particular definition. So this controller is actually defined in the file controller.js or controller.ts, and we can jump to that just by doing go to definition. I can also find out where the controller is used, and when I do find usages, the Explorer here converts into changes its mode to show me the various usages. So I can click on any of those. Okay, I can see that it's exported. I can see that it's imported over here. I can see that it's used as a type in this this construction over here, and so on. So the Explorer over on the left-hand side has two modes. You can have the file mode, where you're seeing the files in your project, and you can have the usages mode, which is showing you the usages for the previous query that you just did. Like I said, it's a live coding environment, so I should show you that I can run it by hitting the launch program, and I can stop the program too there. And make a little space here. You can also see that the documentation, which is a rendering of the README file over here, the documentation is rendered over here. The documentation supports MathJax, and it also allows you to embed code snippets so that you can kind of comment on, for example, how some mathematics was implemented in code. Oftentimes, I might want to see the documentation, and I might want to see the runtime. I could do that by hiding the code, and so I get this kind of like show and tell kind of view. On the other hand, I might want to have the code because I'm developing it, but I don't want to see the documentation, and so I can have that kind of sort of view as well. Okay, and then execution. Obviously, I can build, any kind of application that really, you can build for a website, you can really build in here. So this gives you a lot of flexibility about choosing your libraries, laying things out, and the kinds of things that you want to show. One final thing is probably just to visit a few of the dialogues. So I'm going to visit the project settings. And this shows you that operator overloading is supportable through clicking this checkbox. Now, there's much more to it than that, but that will be a subject of a future video. We can, linting is also automatically supported, so the software is going to make your code as clean as possible, which actually does have a lot of value for making it more readable and understandable for other people. We've got infinite loop detection, so that typing a for loop, for example, doesn't send your browser into a completely locked mode. And then if you want, you can unhide various files that you normally wouldn't want to see, because they're more to do with configuration. Finally, down here, we've got some dependencies that I can elect to use. And you can see here, I've chosen to use this library, DaVinci Newton, library called DOM-Ready. And over on the right-hand side here, you can click and navigate to documentation for that library. Now, STEMCstudio isn't the only way that you can render a project. Clearly, you can share this URL with anybody. Just copy the link and send it to somebody. But you might want to do something a little bit different. Like, for example, let's supposing that you're not really interested in sharing the whole editing environment with them. You just really want to share the runtime. Well, one way to do that is, well, it's kind of quite simple. It works like this. We log in and we upload the project to GitHub. So GitHub now has a copy of the project, and in particular, it has the compiled version of the project, which is what you see here. What that means is that I can go to my URL here and I can use a sister program of STEMCstudio called STEMCViewer. And STEMCViewer basically doesn't have to load up all of the workspace. It just has to run the executable portion of the code, which you can see it's doing here. Now, this is highly configurable. I can bring in the documentation if I want, but the main point is that I have this other option for rendering it. You can also build the HTML that is required to embed STEMCstudio in some other site using this embedding builder, and the embedding builder allows you to choose which files you want to sort of have brought to the user's attention or opened in the editor, and it also allows you to decide what elements of the user interface you actually want to keep in the embedding, so that can be useful for controlling what is seen and what might be a distraction. There is one other way that you can use STEMCstudio, and that is you can launch it from a learning management system. So obviously there's a use case where educators might want to do assessments, or they might want to have an assignment that the student can do that involves computational modeling. And so STEMCstudio can actually be launched using the LTI, that's the Learning Tools Interoperability 1.3 protocol. That will also be the subject of a future video. Well, I'm going to leave it there. There's obviously a lot more to be said about STEMCstudio, but I think it can be the next thing is to really go over the navigation of STEMCstudio, so that if you are interested in using it, you know how to drive and find your way around. From there, we can look at coding and various special niches of STEMCstudio. So I hope you found that useful. If you did and you'd like the video, then please don't forget to hit the like button below. And if you would like to see more of these videos, please subscribe to the channel. Do leave your comments below. Let me know what you think. Give me some feedback. It will dramatically alter the direction that I go in. Tell me what you would like to see. So until next time, enjoy playing in the STEMCstudio sandbox, and take care, everyone.